Hi there, Algebra 2. We're going 3-2, solving systems, algebraically. We've done this last year, probably in Algebra 1 a little bit. Objective, to solve linear systems algebraically. Oh, we weren't supposed to skip vocab. Equivalent systems are two equations set equal to each other so that the variable has the same value in each equation. Okay, what is the solution of this inequality? It says solve by using substitution. If I recall from my knowledge, there's a couple different ways you can do this. There's elimination, there's substitution, and there is, what's the other one? What is the other one? I don't know. We'll find out. I know how to do them. I just don't remember what the other one is. Alright, so this one says substitution. So we're going to get both of these to equal y. So we have 3x plus 4y equals 12. Alright, and honestly, you wouldn't have to get them both equal to y. You could do it a couple different ways. The reason that I say get them equal to y is then it's pretty simple and you just set them up next to each other and then you can just move stuff back and forth and solve. Honestly, if you don't want to do it that way, there is one way that you wouldn't have to solve it quite as much that way. There's quite a few different ways to do this. Sorry, I had to get a drink. Alright, so we're only in 3-2. Okay. I was getting worried there. Okay. So, using elimination. Trying to decide which way I want to use it. Let's make it the way that's probably easier for the solving side of this. You could set them both equal to y. I'm not against it, but on this one, I kind of am. I'm going to minus 2x, I get y equals negative 2x plus 10. Okay? Now I can sub that in for my y in here. So I'm going to get 3x plus 4 parentheses negative 2x plus 10. Okay? Equals 12. Alright, you're going to distribute this 4 through there. You're going to get negative 8x plus 40 equals 12. 3x plus, okay, you're going to get negative 5x plus 40 equals 12. Now I'm going to minus this, minus that. Okay. At that point, we're going to get what, 28? Negative 28, y, so negative 5x equals negative 28, divided by negative 5, divided by negative 5, x equals 28 over 5. Okay? There, you can do it that way. You could have, like I said, you could have solved both of them for y and then subbed them in there. It does not matter. You could realistically simplify that down and your calculator or something, and you are going to end up getting, I think, should go in there 5, which would leave me 3, which would be 0.6. So 5.6 is what x equals on that one. Okay, let's do the next one. Okay. Now, here's another way we can do it. This one, which one's easier to solve for, x or y? Well, I'd say the top one would be really easy to solve for x. X plus 4y equals 5. Minus 4y, x equals negative 4y plus 5. Alright, now you sub that into the second one. We have negative 2 times x, which is going to be negative 4y plus 5. you're going to get 8y. You're going to get minus 10 minus 4y equals negative 5. When I added those two together, I'm going to get 4y minus 10 equals negative 5 plus 10 plus 10. You're going to get 5 over here, 4y equals 5. Divide by 4, divide by 4. You get y equals 5 over 4, which would be 1.25. Okay. Now, and I forgot to do this in the first one, we know what y is now. So we have to go solve that for x now. So, x plus 4 times 5 over 4, which is going to cross reduce, and you're going to have x plus 5 equals 5. Minus 5, minus 5, x must equal 0. Those are what my two values in which they cross will be. And I apologize, I did not do that on the first one, but it should have worked. As long as I did everything completely right. Okay. Solving by elimination. I'm trying to think if this is my favorite one yet or not. I don't think so, but okay. Neither one of these is overly great for solving by elimination. Honestly, it probably would have been my choice to do it this way, to be honest. I don't think. No, okay. Okay. Because I'm going to have to multiply my top one by something so I can eliminate something. Because I'm going to need it where either my x eliminates or my y eliminates. So let's go with my x. So the top one, I'm going to multiply that by 3 and get 12x plus 6y equals 27. I'm going to do the bottom by negative 4, so I get 12, negative 12x minus 20y. And we're going to multiply by negative here. Multiply by negative 4, so we're going to get 20 there. So we end up, that cancels out. This is going to give me negative 14y. And I think this will get me 47. Making sure I did everything right. Divide by negative 14, divide by negative 14, y equals 47 over negative 14. Seems like a weird solution here. Let's make life easier. This is what the book has. Let's check the other one. I was going to say, that didn't seem like a very good one to start out with. Alright, and of course it was a typo error on my part. So, let's try this one first. Okay, this is the type of problem I was assuming if you're going to be using elimination. The other one, I don't like using elimination for that one. I would have rather went back to what we were doing right before that and used substitution in that case. I'd feel a lot more comfortable. Elimination works really well when this one and this one are the same, but they are opposite signs, or they are the same, because we can change the sign very easily. That's going to be gone. This gets me 5. This gets me 25. Divide by 5. Divide by 5. y equals 5. Now, you just sub that into one of these, so you get 4x plus 2 times 5 is 10 equals 9 minus 10 minus 10. You end up with 4x equals negative 1. Divide by 4, divide by 4, x equals negative 1/4. So your inequality, solution for these inequalities is negative 1/4, 5 is where they will cross. Okay? Like I said, if these two are not the same, or basically where I can just change the sign, or really easy to multiply, I am probably not choosing elimination. I do like elimination, but only when it works out this easy. Okay? Now we have this next one where we have negative 2x. Let me get a different marker because I'm dying. Negative 2x plus 8y equals negative 8. You have 5x minus 8y equals 20. Okay, that is going to be gone. This is 3x equals 12. Divide by 3, divide by 3, x equals 4. Alright, sub that back in. I'm probably going to go into this one because it's easier to multiply. 20 minus 8y equals 20. We're going to go minus 20, minus 20. Equals 0, divide by negative 8. Divide by negative 8, y equals 0. So my ordered pair here is 4, 0. That's my solution for that one. Honestly, if you can cross out two of them by lining them over top of each other, I would choose elimination every time. Every time. Or if this one, for example, is positive, then I just come in and change the sign on everything and make it work where I could just cancel stuff out. That would make life super duper easy. Good. Solving equivalent systems. So, these make sure I got the right equation since I messed up already once. Okay, so on these equivalent system, I think once again I'm probably gonna maybe push a little bit towards the elimination one here. You wouldn't have to. You could do substitution, I'm pretty sure, but I'm going to do elimination because I like elimination. And these numbers ain't very big. So it's kind of like what I was doing when I had the problem wrong on the last one. I would take 2x plus 7y equals 4, and I have 3x plus 5y equals negative 5. What I'm thinking is I might multiply the top by negative 3, so I get negative 6x plus negative 21y equals negative 12. The bottom I'm going to multiply by 2, so I get 6x plus 10y equals negative 10. Okay, that's going to be gone. When I do this, I'm going to get negative 11y equals negative 22. Divide by negative 11. Divide by negative 11. y equals 2. Sub 2 back into y. I'm going to get 2x plus 14 equals 4 minus 10, or minus 14. Do it to both sides here. Gone. 2x equals negative 10. Divide by 2. Divide by 2. X equals negative 5. So your ordered parent in this one, where these two inequalities work, is right here. Okay? Okay. Now we can do the next one the same way. That one is a little bigger numbers. I'm guessing, I'm not seeing an easy way of doing this. I honestly might do the y's. The reason that I'm going to do the y's is the top I only got to multiply by 2. So I get 6x plus 14y equals 30. The bottom though, I'm going to have to multiply by negative 7, so I get negative 35x minus 14y equals, it's a negative and negative, so this is going to be 28. These are gone. That's going to leave me with negative 29. X equals 58. Divide by negative 29. X equals, I'm pretty sure that's a negative 2. Plug in negative 2, I would say probably to my top equation, which is going to give me negative 4 plus 7y equals 4. Add 4 over. You're going to get 7y equals 8. Divide by 7. Y equals 8 over 7. So your order pair is negative 2, 8 over 7. Okay? No, my luck, there is a word problem. Okay, so now you're solving with unique solutions. Okay? Okay. What are the solutions of the following system? And you have to explain why. Okay. First one, I'm going to multiply that by 2. I'm going to get negative 2x negative 2x plus 2y equals negative 2. You get 2x minus negative 2 equals 0. You go, you cross out, I'm going to have 0 over here. Over here, I'm going to end up with negative 2. Does that equal? No. Okay? So what does that tell me if those do not equal each other? Well, it probably tells us that there's going to be no solution, would be my assumption. If I was a betting man. Because these two cannot equal each other, which we learned that a long time ago. No solution. Boom. Okay, let's do the bottom one again. That one's probably not too tough either. Like I said, I like elimination. I don't know why. I thought there's one more, but I'm not seeing it in the book, and I have not came up with it myself. Alright, so multiply the top by negative 3, I get negative 12x plus negative 3y equals negative 18. Okay? This is still 12x plus 3y equals 18. Gone. You get 0 equals 0. Okay? Pretty sure that's all real numbers. Trying to think if there's a Like I said though, I was thinking that we probably could have went the other way. There's your homework.